Okay, so I kind of worked out. Think you can hear me. You can hear me, right? Okay. I kind of worked out the problem we had. So whether this one is it? No, this pen doesn't appear. Okay, what is this? This is the question we had. So I kind of worked out in my note. So let's see. えーと、So maybe I have to download this and this. How to download? Okay. So we have download this one. Strange one. Okay. So we have this equation in 7. Oh my god. 720. I'm sorry, I cannot draw anything on top of this picture. So let me see. This is just a t. Okay, so xi prime, which is a particle for particle x, but time is t prime. This position in material coordinate is expressed in terms of the material coordinate at time t. Then this is also about particle x. So you have a material coordinate xj when the time is t. Okay. Then in the material coordinate, we have two primed material coordinate and unprimed material coordinate. And there is a relation between prime and unprimed material coordinate. So first, the unprimed coordinate has to be rotated according to qji. Then the origin should be changed by some function of time only. Then we can compare the velocity. This is just, we consider the velocity of left-hand side. So we take a derivative of xi prime with respect to t prime. Then the derivative with respect to t prime is the same thing as derivative with respect to t. So xj change to vj, first of all. Then qij is also a function of time. So qij becomes qij dot. Then this bt is also a function of time. So bi becomes b dot. Okay. So then we have this. Then we take a partial k prime on left-hand side. And partial k applies to vi here. Yeah, because qij is maybe not, I'm not sure, is it function of Is it a function of xk, primed k? I got some confusion. I'm sorry, I got some confusion. Is this qi also a function of primed x or primed unprimed x? Maybe not. This is just a kind of a constant, right? This is constant, I think. This is, I think, a constant rotation matrix. So the partial k prime apply to only vi. Then there's a qij dot. Then partial k prime, which applies to xj. And partial k prime also apply to b. But b is actually just a function of time. Then this partial derivative means we don't move t, we fix t constant, then take derivative with respect to xk prime. So this last time becomes 0. And if I write this second time out, this goes like partial xj divided by partial xk prime. Right? So then the question is here. This partial k prime vi, what is this? So we have partial k, then we put some intermediate parameter xl, where L summation assumed. Okay, so we have partial xl divided by partial xk prime multiplied by partial vi, partial xl. Then the question is, what is this? Partial xl, partial xk prime. Yeah. So then we have second page. Let me keep this. Second page is like this. Oh my god, this is same picture. Wow. This is just the same picture. What is this one, maybe? So to obtain this, we have to start from 716. 716, we state the relationship between primed x and unprimed x. Yeah. So then here, what is this? We put the second one is just velocity, right? No. Second one is like a spatial derivative. I got confused. Did I do? So this one, what I did is we took time derivative first, so it become x become velocity, right? Then we did partial k prime derivative. So now we do partial k differentiation directly xi partial prime, right? So we see this. You can see this qij here. This is not affected by partial k prime. But the next part, xj is affected by partial k prime. Then the last term is not affected. This goes to 0 because bit is just a function of t. Then if I take partial k prime, t is constant. So this last term becomes 0. Right? So then we want to take this qij on the right hand side out. Yeah. So in order to do this, we multiply QLI, like Q transpose. You multiply Q transpose, okay? Then this multiplication gives, because I is a common parameter of implying summation. So that finally you obtain identity matrix. Identity matrix, it can be written as a Kronecker delta like this. So because we multiply this Q transpose on the right hand side, we also multiply this Q transpose Ly on the left hand side. And we look at the left hand side. Yeah. The left hand side is this prime k x prime. This is delta function. No, Kronecker delta. So then the I, parameter I is for summation. Yeah? So then I actually goes to k here. On the right hand side, we see this Lj, J go to L. So this J is for summation. So they change, J changes to L like this. So then finally we have this Q transpose Lk equal partial k prime xl. And this transpose, you just swap index. So qkl, right? So we obtain this relation. Partial k prime xl is qkl. What is it? Sorry. Partial k prime, partial xl, partial k prime is qkl. Yeah? qkl. So we obtain this relation. So this one, partial xl qk qxk prime is become qkl. A same logic can be applied here. xj x partial xj partial x prime k. This goes like qkj. Yeah? So this goes like this. So this is not objective. Yeah, objective because you have second term. Objective. If this is objective, you don't have second term. But deformation, if you consider deformation rate, I'm sorry, I actually don't remember the exact definition of this deformation rate, but it seems like the average of this partial k prime vi prime plus partial I prime vk prime. So here this is swapped. I'm sorry, I cannot get a pen here, so I use cursor. So here ki, the second term is ik, so this index is swapped. Then you divide by 2, so this is more like average of this. Then you have first term, ik. I don't know if you swap ik. What's happening? You can swap ik. Okay. This one also I have to work out. IJQL. Let me see. I don't know if I can. Okay. So you can see here. This is a KI. You can have. See, I don't get pen. What happened? What's happening here? I don't understand this. I don't get pen. Sorry, I don't get pen. I don't know what to do. Usually we have a pen here. Strange. I have pen now. Okay, so we consider the other case, right? Partial I prime bk prime. So this is ik ki ik. So in this case, you have q I goes to k, j, q, k goes I, l, partial l, vj. So this is common. This is common, right? I would say. So the question is whether this qij qijkl are they same? That's a question. Whether is this same? LJJ. Then you have I goes to K, Q dot, K, J, Q, I, J. Yeah? IJKJ, IJKJ. So then L goes to I, J goes to K. IK, DIK. Okay. So this is more like symmetric. IJKL. KJIL. I don't know how do we prove this? Qij QKL. This has to be equal to QKJ QIL. How do you prove it? IK K K go to I L LJ. I think we swap L and J here. We just swap L, we make J, J we make L, L we make J, and J we make L. So then these things become same, right? So then we have LJ, LJ, and JL. And this average is DJL. It's average. So you have this one, where the second term is 0. The second term is 0. This is the time derivative of identity matrix, I think. JK. This is more like time derivative of identity matrix, which is 0. Thus, D is objective as IJ, J go to, you make J, hey, this is like D, you change K to J, okay. So then J, you can change K to J, K to J, K to J, yeah. So then you change K to J, Q, I, J, see, we have to change J to other thing here on the right hand side, because J is already used on the left hand side. So you have I, M, then Q, you use K to J, use, and L, just use L, and D, J, cannot use, you have to use M, then you can use L, right? So I am J, N, so we use N instead of L. Okay, so then we have this form. We have this form. we assemble the spin tensor, we find something like this. I think we skip a spin part. I think I cannot handle this much. So I skip spin tensor, then we go to the objective measure of rotation. Oh my god. Objective measure of rotation. Integrity basis. A little bit more, but I don't know, I don't think I can go into this part. Okay, let me stop here today. Okay, thank you.